Hello friends, today I'm going to talk about the domain name system, which is also called DNS. When the internet was small, mapping was done by the host file. The host file has only two columns, which is name and address. Every host could store the host file on its disk and update it periodically from a master host file. When a program or a user want to map a name to an address, the host consulted to host file and found the mapping. Today, however, it is impossible to have one single host file to relate every address with a name and vice versa. The host file would be too large to store in every host. In addition, it would be impossible to update all host files every time there was a change. One solution would be store the entire host file in a single computer and allow access to this centralized information to every computer that needs mapping. But we know that this would create a huge amount of traffic on the internet. Another solution, the one used today, is to divide the huge amount of information into smaller parts and store each part on a different computer. In this method, the host that needs mapping can contact the closest computer holding the needed information. This method is used by the domain name system. In this chapter, we first discuss the concept and ideas behind DNS, then we describe the DNS protocol itself. The diagram below shows the external name queries directed by the forwarders. Starting from the internal DNS servers, the external queries will be forwarded into an internal IP address which is 10.0.0.1 to the internet using the forwarders. Well, here's another example of using the DNS service. The first topic in this chapter is the namespace. The first topic in this chapter is namespace. To be unambiguous, the namespace assigned to machines must be carefully selected from a namespace with complete control over the binding between the names and IP address. In other words, the name must be unique because the addresses are unique. The namespace that maps each address to a unique name can be organized in two ways, a flat or hierarchical. In a flat namespace, a name is assigned to an address. A name in this space is a sequence of characters without structure. The main disadvantage of a flat namespace is that it cannot be used in a large system such as the internet because it must be centrally controlled to avoid ambiguity and duplication. Whereas the hierarchical namespace, each name is made of several parts. The first part can define the nature of organization. The second part can define the name of organization. The third part can define departments in the organization and so on. In this case, the authority is assigned to control the namespaces can be decentralized, and the organization can suffix the name to define its host and resource. In this chapter is the domain namespace. A domain namespace was designed to have a hierarchical namespace. In this design, the names are defined in an inverted tree structure with the root at the top. The tree can only have 128 levels, where level 0 is the root to level 127. Please refer to the example below. Each node in the tree has a label, which is a string with a maximum of 63 characters. The root label is a null string, which is also called an empty string. DNS required that children of the nodes that branch from the same node have different labels, which guarantees the uniqueness of domain names. Each node in the tree has a domain name. The full domain name is a sequence of labels separated by dots. The domain names are always read from the node up to the root. The first label is the label of the root, which is null. This means that a full domain name always ends in a null label, which means the last character is a dot because the null string is nothing. The diagram below shows some domain names and also the labels. If a label is terminated by a null string, it is called a fully qualified domain name. And fully qualified domain name is a domain name that contains the full name of a host. It contains all labels from the most specific to the most general. that uniquely define the name of the host. For example, the domain name. If a label is not terminated by a null string, it is called partially qualified domain name. A partially qualified domain name starts from a node, but it does not reach the root. It is used when the name to be resolved belongs to the same site as the client. Here the resolver can supply the missing part called the suffix. To create an Here is the resolver can supply the missing part called the suffix to create a fully qualified domain name. For example, if a user at fhda.edu cites wants to get the IP address of the challenger computer, he or she can define the partial name. The DNS client adds the suffix atc.fhda.edu before passing the address to the DNS server. The DNS client normally holds a list of suffix. The following can be the list of suffix at the ANZA College. A null suffix defines nothing. The suffix is added when the user defines a fully qualified domain name. A domain is a subtree of a domain namespace. The name of the domain is the domain name of the node at the top of the subtree. The diagram below shows some domains. Note that the domain may itself be divided into domains or subdomains as they are sometimes called. The third topic in this chapter is distribution of namespace. Hierarchy of names servers is the solutions to distribute the information among many computers called DNS servers. One way to do this is to divide the whole space into many domains based on the first level. In other words, we let the root stand alone and create as many domains as there are first level nodes. Because a domain is created in this way could be very large. DNS allows domain to be divided further into smaller domains or subdomains. Each server can be responsible for either a large or a small domain. In other words, we have the hierarchy of servers in the same way that we have hierarchy of names on the below diagram. The zone refers to what a server is responsible for or have authority over. If a server accepts responsibility for a domain and does not divide domain into smaller domains, domain and zone refers to the same thing. Server makes database to keep all information for every node under that domain. If a server divides domains into subdomains, domains and zone refers to different things. Information about subdomains stored in servers at lower levels, with original server keeping some reference to these lower levels. Still, original server has its own zone but detailed information kept at lower levels. The root server is a server whose zone consists of whole trees. It does not store any information about domain but delegates its authority to other servers keeping reference. There are two types of root servers. The primary server stores file about the zone in which is an authority responsible for creating, maintaining and updating zone file, stores on local disk. The secondary server transfers complete information about the zone from another server and stores on its local disk. Neither creates or updates zone files. If updating required, it is done by the primary server which sends update to secondary server. Both servers have authority for the zones they serve. The fourth topic in this chapter is DNS in the Internet. DNS is a protocol that can be used in different platforms. In the Internet, the domain namespace is divided into three different sections: the generic domains, the country domains, and the inverse domains. The diagram below shows the DNS used in the Internet. The generic domains define registered host according to their generic behavior. Each node in the tree defines a domain, which is an index to the domain namespace database. By looking at the tree above, we see that the first level in the generic domains section allows 14 possible labels. These labels describe the organization types as listed in the table below. The arrow is used for airlines and aerospace companies. The biz is used for business or firms, which is similar to com. The com is used for commercial organizations. The co-op is used for cooperative business organizations. The edu is used for educational institutions. The gov is used for government institutions. The info is used for information service providers. The int is used for international organization. The MIL is used for military groups. The museum is used for museum or other non-profit organizations. The name is used for personal names, which is individuals. The NET is used for network support centers. The ORG is used for non-profit organizations. The PRO is used for professional individual organizations. The country domains section used two-character country abbreviations. For example, the United States use US as their label. Second labels can be organizational or they can be more specific national designations. The United States, for example, use states abbreviation as the subdivision of US. For example, CA.US. The inverse domain is used to map an address to a name. This may happen, for example, when a server has received a request from a client to do a task. Although the server has a file that contains a list of authorized clients, only the IP address of the client is extracted from the received IP packet is listed. The server asks its resolver to send a query to the DNS server to map an address to a name to determine if the client is on the authorized list. This type of query is called inverse or pointer. To handle a pointer query, the inverse domain is added to a domain namespace with the first level node called ARPA. The second level is also one single node named inaddr. The rest of the domain defines IP address. The servers can handle the inverse domain are also hierarchical. This means the netted part of the address should be at the higher level than the subnetted part, and the subnetted part higher than the hostile part. In this way, a server serving the whole site at the higher level than the server serving each subnet.